Hello, Mr. Brown here, your science teacher. Today, join me as we take a journey from the coldest to the hottest temperatures in the universe. This video is made for all ages, so gather the whole family and let's do some science today. All right, here we go. Let's use Fahrenheit. I know there's Celsius, I know there's Kelvin, but since we use Fahrenheit here in the United States, I'm just going to use Fahrenheit for this video. Okay? Okay. Let's start way at the bottom. Let's get as cold as we possibly can. That's right. I'm talking absolute zero. Negative 459 degrees below zero. This is as cold as it can possibly get. Way down at the bottom, it is absolute zero, where all motion stops, complete lack of thermal energy. Where am I going to find this? Well, I don't know, go out interstellar space, out between the stars, far beyond the reach of the sun's influence, and you'll be right around absolute zero. All right, from this point, we can only get warmer. There's only one way to go, and that's to get warmer. So let's crank it up a few degrees, and now we've reached negative 361 degrees Fahrenheit, and oxygen can no longer be a solid. It needs to melt into a liquid. What in the world are you going to do with liquid oxygen? I can't think of anything to do with it. Oh, that's right. We can use it to fuel spacecraft. Here you can see a rocket using liquid oxygen to launch in. All right, that's pretty cool. All right, well, let's get a little bit warmer. We've added a degree and we are now at negative 360 degrees below zero. This is what it feels like way out at planet Neptune. All right, so let's take a look. How far out? Beyond Jupiter, beyond Saturn, Uranus, way out at planet Neptune. Yeah, pretty cold out there. All right, so how do we know? Well, we've been there. We sent the Voyager 2 space probe, visited Neptune, and brought back temperature data, so we know. All right, let's get a little bit warmer. We have reached the dark side of the moon. All right, notice I didn't say far side of the moon. I said the dark side, because no matter where you are on the moon, you're going to experience about 2 weeks of darkness, 2 weeks of light every 28 days. All right, so anywhere on the moon can be the dark side. It's called science, right? Anyway, negative 243 degrees below zero. All right, that's pretty chilly. We'll come back to the moon in a little bit and see what it's like on the sunny side. All right, while we're here at the moon, let's take a look at this photo of Apollo 11 back in 1969. You can see the Earth back there. And what's interesting is everybody in the world is in this photo except one person. And that is astronaut Michael Collins, the photographer. Everyone else in the world is located on that blue planet there. And Buzz Aldrin and Neil Armstrong are in that little shuttle right there too. All right, let's get a little bit warmer. We've reached negative 128 degrees below zero, and we're on Earth. The coldest place on Earth, Antarctica. Look at those little penguins. They don't even seem to mind. Let's get warmer, and we'll boost it up to negative 30. We've reached the record cold for Wisconsin, negative 30. All right, let's get a little bit warmer, and we've reached the zero mark, 0 degrees Fahrenheit. You'll find this right in the kitchen, in your freezer, right around there. But I want to get warmer. Let's add some more thermal energy, and we've reached 32 degrees Fahrenheit, and ice can no longer stay a solid. It needs to melt into water. Getting warmer. 57 degrees is the average global temperature on Earth. If you average together all the polar climates with all the tropical climates, you get a nice t-shirt weather 57 degrees. But we need to get even warmer than that. So let's crank the thermostat up to 70, which is normal room temperature. Maybe not for everyone, but 98.6 degrees is traditionally known as normal human body temperature. Although it's not the same for everybody. Let's get even hotter than this. Let's crank it up to 105 degrees. You've reached the hottest recorded day in Wisconsin history, 105. That's a heat wave. But what about the world? The world record took place in the Libyan desert in North Africa, 136 degrees Fahrenheit. No, thank you. But let's get even hotter still. We've reached the point where water can no longer maintain its liquid form. It's going to vaporize into a gas. The boiling point of water, 212 degrees Fahrenheit. Let's get hotter than that. All right, we're back on the moon, and this is the sunlit side of the moon. If you recall, a minute ago, we were on the dark side of the moon, and it was like negative 250 something, and now we are 500 degrees difference between sunlight and darkness. All right, that's what happens when you don't have an atmosphere. Moving on, 350 degrees. Let's jump in the oven and bake some cookies. Can you smell this slide? Smell them baking cookies. But we need to get even hotter than that. We have reached 800 degrees, and we are in one of those fancy restaurant pizza ovens. You've seen these before, right? And you can feel the heat coming off of them. We need to get hotter. Let's add some more thermal energy, and we are on the surface of Venus. In 1981, the Soviets put a probe on the surface of Venus, and they sent back data, 864 degrees, even at the poles. That's a hot planet. All right, we are now at 1,652 degrees, the tip of a lit cigarette. Wow, who would have thought that? I'll tell you. All right, let's get even warmer than that. And it's time to melt gold. We're at 1,948 degrees Fahrenheit, and gold turns into a liquid. Let's get even hotter than that, and we reach the melting point of iron. We're at 2,800 degrees Fahrenheit, and we're still getting hotter. In fact, we're getting so hot that we are melting rock. Rock turns into liquid lava, 3,600 degrees. This is starting to get crazy. Let's add more heat. 10,000 degrees Fahrenheit. We're on the surface of the sun. Put your finger on the screen. Oh, that is hot. There is no way we can get hotter than this. Oh, yes, we can. 27 million degrees. We are in the inner core of the sun. So hot, thermonuclear reactions are taking place. There is nothing that can get hotter than this. There's one place I found hotter than this, and that is a supernova star explosion, 100 billion degrees Fahrenheit. All right, that was epic. Thank you for joining me on a journey from the hottest to the coldest temperatures. I'm Mr. Brown, your science teacher, and I'll see you next time. Bye-bye.